In these two sample problems, we're finding side lengths of similar figures, or missing side lengths of similar figures. In order to do that, you need to understand that side lengths are proportional to each other in similar figures. So just like the problems we've been setting up for the past couple of days, we're going to set proportions to figure this out. So we're comparing rectangle 1 to rectangle 2. In these rectangles, we need to find a side that we know. So for instance, I know this side is 12 feet, but be careful because the orientation of those rectangles is not the same. For instance, this one's the bigger one's kind of laying on its side, where the smaller one is standing up. Its longer side is going up and down. So if I'm going to compare 12 feet, I got to compare that to side A because they're the corresponding sides. Then the side that I know for both is this 9 foot, which is the shorter side, which goes with the 5 foot. So not only am I going to compare rectangle 1 to rectangle 2, but I'm going to compare the base or the width to the height. And we're going to separate proportion to do that. Okay, so do I know the base of rectangle 1? Yes, I know the base of rectangle 1 is 9 feet. Do I know the base of rectangle 2? Yes, it is 5 feet. Do I know the height of rectangle 1? Yeah, it's 12. And I'm looking for the height of rectangle 2. Now we're going to cross multiply, so I get 9 times A is 9A. I get 12 times 5 is 60. Divide both sides by 9. So we have 60 divided by 9. And I get 6.67. And since we're talking about rectangles, we have units, so we have 6.67 feet. Here in problem number 2, we are comparing triangles now. The one thing that's a little bit different with this one is that we have two missing side lengths now, T and E. You can't find both at the same time though, so we're going to have to compare both of them to the base because the base is the only side that we know for both figures. So let's start with T. The corresponding side to T says T is a hypotenuse to that right triangle. So the corresponding side is the 11.2 inches. So if I'm going to compare triangle 1 to triangle 2. And we're going to compare the base to the hypotenuse. And I'm going to set my proportion. So in triangle 1, do I know the base? Yes, the base is 5.7 inches. Triangle 2, do I know the base? Yes, the base is 9.1 inches. Triangle 1, do I know the hypotenuse? It's 11.2. In triangle 2, we have T. So I'm going to cross multiply, and I get 5.7T is equal to 9.1 times 11.2, which gives me 101.92. And if I divide by both sides by 5.7, I get 17.88. So T is equal to 17.88. In this particular problem, we're talking about inches. So I have 17.88 inches. Okay, since I rounded that one off, I'm not going to use the hypotenuse to try to figure out the height. I'm going to go back to the base because I know the exact answer for the base. So let's set it up again. So I have triangle 1 and triangle 2. I have height versus base. And let's set up a proportion. So the height of triangle 1 is 9.6. The height of triangle 2 is E. We don't know that one. We have the base of triangle 1 is 5.7. The base of triangle 2 is 9.1. So now we cross multiply. We have 9.6 times 9.1. And we divide both sides by, hold on 1 second. So we have 87.36. And then we have 5.7 times E. So there we're going to divide by 5.7. And I get 15.33. So E is equal to 15.33 inches. So if I go back to the picture, I have 15.33 inches for the height of my triangle.